more. We draw the superhex, write the number 1 at the center, tan equals sine by cos, cot opposite to tan, and cosec here since all c's have to be on the right, and what remains is sec. I repeat the positions again and again so it gets etched in your brain after watching the video. Take any 3 continuous functions in the hexagon like tan, sine and cos. Tan multiplied by cos will give us sine. So if 3 continuous functions are taken, the product of the first and the third functions result in the function in between them. We can say that tan theta multiplied by cos theta equals sine theta. Take these 3 functions for example. This multiplied by this will give cosec. So sec theta multiplied by cot theta will give us cosec theta. Even cot multiplied by sine will give us cos. Cosec multiplied by tan will give us sec, and so on. First term multiplied by the third term will give us the term in between them. Does it end here? Not yet. Let's redraw the hexagon with 1 in the center. Tan is equal to sine by cos, cot opposite to tan, cosec here as all c's on the right, and what remains is sec. Now focus on the functions at diagonally opposite vertices. Sine and cosec, cos and sec, cot and tan. They are reciprocals of each other. Look at this arrow for instance. This arrow tells us that sine theta equals 1 by cosec theta. What about this arrow? This arrow tells us that cos theta is 1 by sec theta. And this arrow tells us that cot theta equals 1 by tan theta. If the arrow is drawn like this, we can even say that cosec theta is reciprocal of sine theta. So remember, functions at diagonally opposite vertices are reciprocals of each other. Be patient, it doesn't end here. But let's review what we have covered so far. This equals this by this, or this equals this by this. This multiplied by this equals 1, or this multiplied by this equals 1. This multiplied by this equals this, and this is equal to reciprocal of this. Let's draw the superhex again to know the other stuff it tells us. Tan is equal to sine by cos, cot opposite to tan, cosec here as all c's are on the right hand side, and the remaining function sec here. Do you remember complementary angles? Yes, 2 angles are complementary if their sum equals 90 degrees. And the trigonometric functions had a special relation with complementary angles. Look at this arrow. What does it tell us about sine and cos? It tells us that sine of theta equals cos of 90 degrees minus theta. This horizontal arrow tells us that sine of an angle is equal to the cosine of its complementary angle. Similarly, this arrow tells us that tan theta equals cot of 90 degrees minus theta. And this arrow tells us that sec theta equals cosec 90 degrees minus theta. And if the arrow is drawn this way, it will tell us that cos of theta equals sine of 90 degrees minus theta. So a horizontal arrow tells us that one function of an angle is equal to the other function of its complementary angle. I think I have lost track of how many formulae the superhex has helped us remember. And there's more. This is the superhex again with a 1 in the center. Tan is equal to sine by cos, cot opposite to tan. Cosec is written here as we have all the c's on the right hand side, and the only remaining function sec is written here. Look at the figure. There are 6 triangles formed inside. Focus on 3. This one, and this one. Let's zoom out slightly. Okay, so here we go clockwise within each of the triangles starting with top left position. Like this: sine, cos and 1. This gives us one very important identity. This squared plus this squared equals this squared. So sine squared theta plus cos squared theta equals 1. Now let's go clockwise in this triangle. This squared plus this squared will equal this squared. 1 plus cot squared theta will equal cosec squared theta. If we go clockwise in this triangle, we get tan squared theta plus 1 equals sec squared theta. Amazing, isn't it? This arrow can also be drawn anti-clockwise from the bottom of the triangle, like this. The only difference with anti-clockwise is that there will be a minus sign before the second term. So it will be this squared minus this squared equals this squared. So we can say that 1 minus cos squared theta will equal sine squared theta. Similarly, if these two also became anti-clockwise, we get two more results. Cosec squared theta minus cot squared theta equals 1. And sec squared theta minus 1 equals tan squared theta. Now you know why we call it super. One hexagon helped us with so many formulae in trigonometry. But hang on, you have to practice this procedure well, because there are a few things you need to remember here too. The position of the functions, the directions of arrows, and so on. This video is not a substitute for all the other videos done before this. It's just an add-on. Memorizing formulae can never be the solution. Make sure you understand all the formulae we derived in the previous videos.